Hello, in this lesson we're going to talk about the Zeroth Law of Thermodynamics and its applications. Before talking about the Zeroth Law of Thermodynamics, let's discuss about temperature. Well, temperature is intimately related to our perceptions of hot and cold. And we also know that when the temperature of an object changes, other properties also change. This happens because we have a thermal or heat interaction. And when all changes in such observable properties cease, the interaction is at an end. And when it happens, we say that the object reached a thermal equilibrium. Now that you know what is thermal equilibrium, let me show you the Zeroth Law of Thermodynamics. Well, the Zeroth Law states that if two bodies are separately in thermal equilibrium with a third body, then they are also in thermal equilibrium with each other. Let's imagine we have three objects, A, B, and C, and if A is in thermal equilibrium with B, and B is in thermal equilibrium with C, then A is also in thermal equilibrium with C. It may be very simple, but it can be very useful. For example, to know if A and B are in thermal equilibrium, instead of measuring the temperature of A and B, you can just add one object to the system and wait until it reaches thermal equilibrium. And then you can measure the temperature of A and B through a third object. One of the most common applications of the Zeroth Law of Thermodynamics is in thermometers. So a thermometer can be any object with at least one measurable property that changes as its temperature changes. So for example, in this kind of thermometer here, the volume changes as we have a change in temperature. If it increases, the volume of the liquid inside the thermometer expands. If you want to know more about this kind of thermometers and how this expansion works, check out our other video about thermal expansion. Another kind of thermometer that's very useful are that one based on the electrical resistance. So changing the temperature changes the electrical resistance of the object here, thermometer. Also, we have some thermometers that work with radiation. They're a little bit different. You don't need to put it in contact with another object to know its temperature. We just need to point and we can measure the temperature by radiation. Alright, so let's practice a little bit. Imagine the system here. We have a room with two beakers of water in it. One of the beakers is 11 degrees Celsius higher than the room temperature, and the other one is 11 degrees Celsius lower than room temperature. So after some time, they reach an equilibrium, a thermal equilibrium. So the question is, what is the difference between the temperatures of the waters in the beakers after the equilibrium? Well, if you remember the concept of thermal equilibrium, you know that actually there are no differences between the temperatures of the beaker. They will be all in the same temperature. And this temperature will also be the room temperature. Because if you have two objects in thermal equilibrium, and this one is in thermal equilibrium with the room, and this one will also be in thermal equilibrium with the room. It means they are all in the same temperature. Alright, now it's your turn to think about it. So we have two objects, A and B, with temperatures T1 equals to 158 Kelvin and T2 equals to 169 Kelvin respectively, and they are each in a closed system. They are brought into thermal contact and enough time passes. So if the final temperature of both objects is Tf, what is the relation between T1, T2, and Tf. So think about it, try to remember the concept of thermal equilibrium, and write your answers in the comment sections. Thank you.
If you found this video helpful, remember to subscribe and stay tuned.